So, section 2.2 of the guided notes, 2.2. And due to the mix-up in the packet, hopefully you can find your page that looks exactly like this. And this is for section 2.2. You might want to indicate that at the top. And let's begin. Absolute value equations differ from linear equations in that they have two solutions. Now, you're used to finding x equals like one number. But an absolute value, x actually can equal two different numbers. And you'll get the same value for y. So we're going to get some experience with this. So you're used to seeing so far absolute value functions equal to y. And if you were to go to Desmos, and you could adjust your slider, right? That's H, that's K, and there's A. So if you type this into Desmos or adjusted your sliders, you would get exactly this graph. So that's what you've already done. Right, and knowing this, we know because H is 5, right, our vertex is at 5 and -4. And so if I start at, let's say 5 and -4, let me plot that. Now that's here, about there. Right, and then if I were to graph this by hand, like so, and we could find a bunch of points. So let's try that. So when I plug in 6, right, at least if I'm plugging it into something like this, I'm going to get 2 times the absolute value of 6 minus 5 minus 4. Right, what's that equal to? 6 minus 5 is 1, and the absolute value of 1 is 1, and all that's being multiplied by 2 and then subtracted by 4. So you have basically 2 minus 4, which is equal to a -2. So we know if this is -2, that is -2. So let's now plot those points there and there, and there and there. And we can try one more. Let's see here. What happens if I plug in 7? 2 times 7, the absolute value of 7 minus 5 minus 4. Right, you're going to get the absolute value of 2, and it's going to be 2 times 2 minus 4. And that's 4 minus 4, you get 0. So if this is 0, that is 0, and something like this. Now all this so far is the same as what you've been doing over the last 3 or 4 days. So the only difference here is now you want to find out when this thing is equal to 2. So one way you can do that when you're using a graph is you can actually draw the line y equals 2. And this is something you could also type into Desmos. Right, if I type this into Desmos and this into Desmos, I would get RV, and I'd also get a horizontal line. So I would get this horizontal line at 2, because that's the graph of y equals 2. And then I would get the v, which would continue on to here and here. Right, and basically you can see that this graph is equal to 2 in 2 spots. And where are those spots? Right? right? The graph is equal to 2 there, and the graph is equal to 2 there. So what are those values for x, right? Well, for this particular equation, this is equal to 2 when x is apparently equal to 2, and when x is equal to 8. And now you can actually test the solutions and see if they work. Let's see, what is 2 minus 5? That's a negative 3, right? And then the absolute value of negative 3 is 3. 3 times 2 is 6. And 6 minus 4 is 2. So we've checked this one works. And what if I check this other one? Check 8. Right, what is 8 minus 5? Right, that's 3. The absolute value of 3 is 3. 3 times 2 is 6. And 6 minus 4 is 2. So 8 also works. So that's kind of interesting, right? We're used to solving for one value of x, but now we're actually solving for two values of x. And as you can see with the line, this particular graph does have y values equal to 2 at these 2 points for x. So I'll give you a moment to get all that down, and granted I didn't leave you a lot of space, so maybe another sheet of paper might help, but we'll move on to the next section. So this brings us to the next point, and that's how to solve these absolute value functions when they don't equal y, but they equal a particular number if you didn't have a graph. And so we're going to dive into this by hand. This actually starts on this page, but then it's carried over into the next page. So there should be boxes in the next page for this problem, right? It's something like that on the very next page. So you might want to carry your work from there and just maybe write that problem up at the top. So to solve absolute value equations algebraically, first isolate the absolute value expression on one side of the equation the same way you would isolate a variable. Then use this rule. And this rule will help you because basically you're solving two versions of basically a one or two step basic algebra problem. So, but first things first, you're going to need something with x in it equal to something else. You can't have anything else outside of it on either side. So here our first step, right? We've got that 2. We've got to get rid of that 2 before we can really proceed. So hopefully you recognize from Math 1, Section 1, Chapter 1.1 that you did last year around September, and you've been doing ever since the past year. So I have to get rid of that 2, I got to subtract 2 from both sides. So my problem will start off like this. And now it is in a format that I can basically set up the two equations. So one equation will look like this. And the other equation will look like that. And you'll notice all I did is basically I got this to where it was isolated, the absolute value part that is, and then I just made a positive and a negative version of that number. Now from here, you simply solve for x, just like you would every other algebra problem you've seen so far. We drop the brackets, and then if it's multiplied by 3, we divide by 3. So in this section, x is equal to 2. Here we do the same thing. We drop the brackets. It's equal to -6. And then again, we also divide by 3. X equals -2. So basically, x is going to be equal to 2, or x is going to be equal to -2. And if you plug these back into the equation, you don't have to write this down, but I'm just going to do it right now for your understanding, right? Here was our original equation, 3x absolute value plus 2 equals 8. And if we did it right, both answers should work. So what is the absolute value of 3 times 2 plus 2? You get 6, the absolute value of 6 plus 2, right? That is equal to 8. And let me try -2. 3 times a -2 plus 2, is that equal to 8? Well, this becomes the absolute value of -6, which of course is just plain old +6, and 6 plus 2 is equal to 8. So we've checked our work, both solutions work, and that's kind of the way these roll in absolute value. There's going to be 2 answers, or 1 answer, or no answers. So let's we'll get to all those examples in just a moment. So several more examples. If I'm going to set up my 2 equations, basically I'm going to need this 4x minus 5 inside the absolute value symbol is equal to some number. So hopefully you can identify, right? I got to get rid of that 3, and I got to get rid of that 2. I got to do all that before I can even start to set up my 2 equations. So let's basically add 2 to both sides, right? You're going to get 21, and then we're going to divide by 3. So basically you have 19 plus 2 divided by 3. And that's 21 divided by 3, so that's going to be equal to 7. So the absolute value of 4x minus 5 is equal to 7. And now we can begin to set up our 2 equations. We have basically a positive side and a negative side. So we got 4x minus 5, that's not an S, is equal to 7. And the negative side, 4x minus 5 is equal to -7. So now let's begin. We solve both equations, and that'll give us both our answers. So first step, right, drop the brackets. Not 3, 7. Drop the brackets. So if this is 4x minus 5 equals 7, right, add 5 to both sides. You have 4x equals 12, then divide by 4. So on the positive side, x is equal to 3. And in the equation you set up on the negative side, right, and this is kind of, you'll notice how I just basically drew a table and I had 2 halves. This is just a good habit to have if you're solving these by hand. And there will be some questions on the future tests that are exactly like this, solving these by hand. You can also solve them graphically, as you saw when you type one equation into Desmos and then the other equation you set equal to, like, let's say this number, y equals that number, and the 2 points where the graphs intersect will also be your solutions. So let's we're solving this by hand, so drop the brackets. 4x minus 5 equals -7, right? And if it's minus 5, we got to add 5 to both sides. You're going to get 4x is equal to -2. Next step, divide by 4, and you wind up with x equals -1/2. So now let's try this other one, right? I'm going to have to get rid of this -5. I'm going to have to get rid of that 2 before I can solve anything, because I need my problem to look like this. X plus 1 is equal to some number. So we've got to figure out, well, what that number is before we can even begin here and here. So we've got to subtract 2 from both sides, and then you have to divide by a -5. Because that's the opposite of multiply here, and that's the opposite of plus 2 here. So you basically have 12 minus 2 divided by a -5. So 12 minus 2 is 10, and 10 divided by a -5 is going to be equal to a -2. And now we have basically a positive and a negative side with which to begin. So you have bracket x plus 1, close bracket. This is a absolute value of x plus 1 is equal to a -2. Right? This is the side that's unaltered, if you will. And on the other side, I've got x plus 1, the absolute value of that, is equal to, well, what's the opposite of -2? 2. And let's begin, right? We drop the brackets. You got x plus 1 equals -2. Subtract 1 from both sides. You get x equals a -3. And here we have x plus 1 equals 2. Subtract 1, and you'll get x is equal to 1. And right, we've done all the algebra, but perhaps there's one critical piece of understanding that we forgot. And I want you to examine this scenario, right? And have you ever known anything that's absolute value to be equal to a negative number? Question mark, question mark, right? The absolute value of anything is never negative. So even though you got some numbers here, the real answer to this question, and this is a trick one, right, is no solution. There is no solution, right? And you'll remember I did mention how these could have 2 solutions, 1 solution, or no solution. Well, here's a scenario where it has no solution. And if you don't believe me, like let's if you plug in these numbers back into the original equation, then in theory they shouldn't work, right? If there is no solution. So you don't have to write this down, but I'm just going to demonstrate it. I'm going to try one of these numbers, and I don't want you to write this down, right? I want you to know why this is no solution, right? Because an absolute value can never equal a negative number. The absolute value of something could never equal a negative number. That's why it's no solution. But let's just check, right? In case you want to see numerically, and don't write this down. This is strictly for your understanding. So I'm going to write this in a different color, and I'm going to try one of these points. So I'm going to do -5, right? And this is all just my checking work. -5 times the absolute value of -3 plus 1 plus 2 is equal to 12. Right? Oh, and another way you could check this is if you graph this equation into Desmos, and then you also graphed y equals 12 into Desmos, you should find that the two graphs actually don't intersect. So back to where we were. -3 plus 2 or plus 1 is -2. The absolute value of -2 is 2. So right, this times a -5 plus 2. So you get -5 times 2 essentially is -10 plus 2. And is that equal to 12? Question mark, right? You should kind of already know. No, it's not. So if I tested the other solution I came to, it wouldn't work either. And also, if I graph this and this function set equal to y, you'll find that the two graphs don't intersect. Okay, let's do these last two examples. So I've got to get this over there, and I got to get this over there. So before I can even really begin doing my two versions. So the first thing I'm going to do, right, and I'm just drawing that so you can see, like, I can't really get started, so I just have the brackets on one side and a number on another. So eventually I need to have just 2x minus 4 is equal to some number. So let's try to figure out what that number is. So I'm gonna add 3 to both sides, right? And that's gonna become 0 on the other side. These are gonna both cancel. You're gonna get 0, and then you have to divide by a -6, and 0 divided by a -6 is still just 0. So the number that we came up to that this was going to be equal to is in fact 0. So you basically have in brackets 2x minus 4, the absolute value of that is equal to 0. And on the other side, you have 2x minus 4 in brackets is equal to a -0. And you're like, wait, you can't even have -0. Precisely. So this is an example, and I alluded to it earlier in the notes, how you can have, some of these have two solutions, some of them have one solution, and some of them have no solutions. So this particular one will have basically one solution. So when I drop the brackets, I get 2x minus 4 is equal to 0. Then I add 4 to both sides. I get 2x equals 4. Divide by 2, and you get x is equal to 2. Likewise, right, this is going to be the same thing. It's going to be the same answer. Add 4 to both sides, and I'm just doing this for your understanding. Right, and then divide by 2, you get x equals 2. So this one, this particular one has only one answer, basically. And you have some warm-ups that do this as well. And now let's see this last example. Right, I'm going to need eventually 3x minus 4 in brackets is equal to some number. So, right, I'm going to have to subtract 2 from both sides. And when you do that, right, this is going to cancel. And you're going to wind up with something like 3x minus 4, the absolute value of which is equal to -1. And now this is kind of a trick question because, the absolute value of basically anything is always positive. It's always positive. So if it's always positive, and here you're faced with something negative, then this must be no solution. And on a graph, this would look something like, here's your graph, here's your absolute value function, let's say, and then when y is equal to 1, right, the two graphs don't touch. So nowhere ever will there be a place where the graphs touch, and hence no solution. So this concludes our notes for this section, and we'll get going on some fun and exciting HRW activities.